This video is going to look at the 3D coordinate system, whereas in the past we were just looking at having our x and y axis, and now we're going to introduce another axis, the z-axis. Now what we want to do here is we want to think of our x-y axis here laying flat, and if we think of the x and y axis here laying flat, our z-axis is going to be going straight up. And what you'll notice here is we can think of here y and z you're going to visualize as being here flat, and the z-axis is coming out of the screen. And each one of these would be positive values. Coming out of the screen, x is positive, going to the right here is positive, and going up is positive. If I was to take the x-axis now and go back into the screen, that would be our negative x value. And if I take and extend the y-axis here to the left, that would be representing our negative y values. And the z-axis going down would give us negative z values. So if we look over here at the picture here in the middle, we notice we have your x-coordinate, y-coordinate, and z-coordinate. So now what we'll notice is we're going to have an x, y, and z. So instead of having an ordered pair, we have an ordered triple. And they're always going to be your x-coordinate first, your y is second, and your z-coordinate is third. And if we were thinking about locating this point that's here in the picture, your x-coordinate is how far we're coming out. So maybe this distance here coming out, which would be 5. And then maybe here the y-coordinate going over here would be 6. And then maybe here the z is we're going up a distance of 4. So that means we would have the coordinate of 5, 6, and 4. Now what you'll notice if we look over here at the third picture, we see that we have the different planes drawn in here. And if we'll notice here, we have in the orange that is kind of laying here flat, that is represented here. If we go back over here, this is representing the x and y plane. So this orange is the xy plane. And then if we look at the blue, notice that's going this way. That's covering the z-axis and the y-axis here. So that would be the YZ plane. And then in green, that's looking at this part going this way. So this green plane is representing the XZ plane. Okay? Now, what we want to visualize is we know before, if we think of when we just had the X and Y axis, we had our quadrants of 1, 2, 3, and 4. Well, now because we're adding 3 dimensions to it, we're going to have 4, but we're also going to have 4 below that, so we're actually going to have 8 octants here. So if we notice here, if I was to draw kind of a box here coming out to the right and then up, then here we're looking at all of your values x, y, and z being positive, where you're coming out of the screen, going to the right, and going up. This here, kind of in this right front top, is the first octant, okay? And you'll notice if we keep our z value positive, that means we're above this orange xy plane, and that's going to give you the 4 octants on top. So if we were to go back into the screen here, backwards, and if I was to draw a little box back here, we would see that that would be in the second octant. And then if we went over here to the left behind the blue plane, that would be the third octant. And then if we come back to the front over here, this would be in the fourth octant, okay? And then we're going to have 4 below this xy plane. And they're going to start here, so this would be the 5th octant, and then back here would be the 6th, and the 7th would be to the left of that, and then if we come back here to the front bottom left here, this would be the 8th octant. So there we have all 8 octants here. The first 4 are above this orange XY plane where the Z value is positive. And if your Z value is negative, that means we're going down. So the other would be below this XY plane, which is in orange. Okay, so let's see if we can figure out this statement here below. It says the point located 4 units in front of the YZ plane. So if we locate the YZ plane, we're going 4 units in front of that. Well, the YZ plane is here in blue. And if we notice when it says YZ plane, what's missing? Well, the X is missing, so that means we're looking at the X coordinate. So we're coming in front of the plane. That means we're coming here out. So that means we're going a distance of 4. And then it says the next coordinate is 3 units to the left of the XZ plane. So the XZ plane is green. So if we're going to the left of that, that means we're going here over to the left 3 units. So that means that would be a negative value. So that's a negative 3, and that's your Y coordinate. And then we're going 2 units below the XY plane. And if we're going below, that's our Z value, and it's going below or down. So therefore, that would be a negative 2. So to get to this point here, we would be 4, negative 3, negative 2, and that would be located in which quadrant? Well, we know above the XY here in orange, we have the 4, and then we have to drop down below that because we have a negative 2, and we would go around, so that would be 5, 6, 7, and 8, so this would be in the 8th octant. And again, we would use Roman numerals to represent the 8 octants. All right, so now we're going to look at a couple other topics, and this is not going to be very new. We're going to look at how can we find the distance between 2 points. Well, if we recall, we've looked at the distance formula before when we had just 2 dimensions. But now we want to look at what happens if we have a point out in space. Well, if we're given the point, let's say x1, y1, and z1, and the second point we could call x2, y2, and z2. Well, the distance formula before, we would say, well, that's going to be distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we just had xy coordinates on 2 dimensions, that would be the distance between those 2 points. And all we're going to do now is add on the third quadrant, which would simply just be z2 minus z1 squared, and that's going to give us the distance between 2 points in space. So if we look at an example of this, if I was to give us the following 2 points, let's say that we had 4, 1, and 5, and we had 8, 2, and 6, and we want to find the distance between those 2 points, then we could, if it helps you, we could label this one as x1, y1, z1, call this point x2, y2, and z2, and it doesn't matter which one we call x1, y1, z1, or x2, y2, z2. We could switch it around. We just have to be consistent now when we plug into the formula. So we get the distance would be equal to the square root of x2 minus x1, so that would be 8 minus 4 squared, plus the y2 minus y1, so that's 2 minus 1 squared. And then we take our z would be 6 minus 5. And then that's squared. So then we would have 8 minus 4, which is 4, so the 4 squared is 16, plus 2 minus 1 is 1 squared is 1, plus 6 minus 5 is 1, and 1 squared is 1. So then we end up with 16 plus 1 plus 1. So we have the square root of 18. And if we were to take the square root of 18, we could also put that in the calculator, and that would be approximately equal to 4.2. So that would be the distance between those 2 points in space. So you'll realize a lot of these formulas we're going to look at now from 2 space to 3 space are going to be very similar. We just have to add in the third coordinate. As for example, the next one would be the midpoint formula. So if we want to find the midpoint between 2 points, then the formula is simply going to be x1 plus x2 divided by 2. You would take your y's, add those together, divide by 2, and that's what we did for 2 space, but now in 3 space we're going to have to add our z, so z1 plus z2 divided by 2, and that would give us the midpoint between 2 points in space. So if we look at an example of this, what if we had the following points: 9, -5, 1. So we have 9, -2, -4. And we want to find the midpoint. So if we took a line segment and connected these 2 points, we want to find the midpoint that would connect these 2 points together. Well, we're just going to simply take and add our x values together and divide by 2. So 9 plus 9 divided by 2. Then we would take our y values of -5 plus a -2, divide that by 2, and then our z, which would be 1 plus -4 divided by 2, and we would have 9 plus 9 is 18. 18 divided by 2 would be 9. -5 plus a -2 would be a -7 divided by 2, so that would be a -3.5 or -3.5. And 1 plus a -4, so that's really 1 minus 4, so that would be a -3/2, or we could write that as a -1.5. So this would be the midpoint between these 2 points in space. So hopefully you'll realize here that the midpoint and distance formula is very similar to what we did with 2 space. All we have to do is introduce the third z coordinate. So keep in mind here, your 3D coordinate system, we have the x-axis here that's coming out of the screen and going back into the screen. Your y-axis is running left and right, and your z-axis is giving you your height going up and down.